Welcome to an SOS video on exponential functions and how they can be graphed. An exponential function has the variable as the exponent. So this is the form we're used to seeing it in. Y equals a number times the common ratio to the x power. The exponent it has the variable in it. Growth or decay factor, otherwise known as common ratio, is your b value. So to graph an exponential function, we're going to create a table of values. Typically, we have a few small negative numbers, 0, and a few small positive numbers, integers. You plot the ordered pairs and connect them. You don't necessarily have to plot all the ordered pairs in your graph. Sometimes you don't have the number of boxes high enough to graph. So even though it's in the table of values, you don't necessarily have to graph all the pairs. What you do need to do is put an arrow at each of the last points graphed. We do not extend the graph. You're going to see why in a few minutes. And lastly, we label the graph with the equation, just like we've been doing with linear functions. Okay, so let's start with the first one. Y equals 2 to the x. This is an exponential function because the exponent is a variable. So I'm going to use our typical table of values. I have -3, -2, -1, 0, 1, 2, and 3. We take our calculator. You go to y equals, after you turn it on, and you type this in, 2. And remember, to have the exponent, we need to use our caret key, 2 to the x power. We want to have our table of values, so second graph. And at -3, it's 0.125. If your calculator is showing it as a fraction, it would be 1/8. When x is -2, our y value is 0.25, or 1/4. At -1, 0.5, or 1/2. 2 to the 0th power is 1. 2 to the 1st power is 2. 2 squared is 4, and 2 to the 3rd power is 8. So what you're now going to do is plot those points on the graph. Our highest number is 8, and we definitely have 8 boxes, so that's not going to be a problem. When we graph -3 and 0.125, it gets really close to the x-axis but doesn't touch it. So first off, since we know we're going to graph, you're going to label your axes, y and x. To graph -3 and 0.125, start at your origin, -3 for the x, and 0.125 is very close to the x-axis. Then -2 and 0.25, which is 1/4. So -2 for x, I'm going to be a little bit higher, not much higher. Then -1, 0.5 is midway, 1/2 of that box. 0, 1. Then 1, 2, 2, 4, and finally 3, 8, 4, 5, 6, 7, 8. And you notice the pattern is not a straight line, it is a curve. So we are going to connect the dots. Start at your one on the left and connect all the way to the right. We can't extend the curve because we don't know how rapidly it's increasing, but we do want to show that it goes on forever. So I put an arrow right on that first dot and an arrow on that last one, and that means it goes on forever. And then I write the equation y equals 2 to the x power somewhere close to that. Okay, when we have y equals 2 to the x, we're looking at our equation y equals ab to the x. So 2 to the x, that means our b is 2. We don't know our a value. So our a value, what number could I multiply this by that we would still have the equivalent of 2 to the x? The only number would be 1. So our a value is 1. Now let's take a look at our graph. What is the y-intercept? Well, this curve crosses the y-axis at 1. And what is the direction? Direction is, what does that curve look like as I'm going from left to right? And it's going up, so we say the direction is increasing. So something interesting about one of these values in our y-intercept. I want you to think about that, and we're going to take a look at the next graph and see if you're able to pick up on that. Our next graph is y equals 3/2 to the x power. So you go to y equals, clear what you have, and then alpha y equals will give us our fraction, 3/2, okay, to the x power. We're going to get our table of values, and we're going to take a look at that. So when we have -3, because this is going to be our typical table of values, our typical domain, -3 is 8/27, so a very small number, less than 1/2. -2 will be 4/9, that's close to 1/2. When x is -1, that's 2/3, closer to 1. When x is 0, anything to the 0th power is 1. When x is 1, 3/2 to the first power is 3/2, or 1.5. So we keep on going. 3/2 squared is 9 to the 4th power, 9/4. And when the x value is 3, the y value is 27/8. 8 goes into that, that would be 3 3/8. 4 goes into this twice, 2 1/9, if you wanted to change it to that. All right, let's graph this. Remember, when we graph, first thing you want to do is label your axes. So when x is -3, y is 8/27, which is less than 1/2, so it's very close to the x-axis. When x is -2, that's 4/9, which is roughly half. When x is -1, 2/3 of the way here. When x is 0, we have 1. When x is 1, it's 3/2, which is 1 1/2. When x is 2, it's the equivalent of 2 1/9, so a little bit above the 2. When x is 3, it's 3 3/8, so 1, 2, 3 3/8, almost halfway for that box. And what do? We connect the dots. Just start from the left and go to the right. We show it goes on forever by putting an arrow at each end. And we make sure to write the equation, y equals 3/2 x. So we know our b value, the one right next to x, is 3/2. There's no other number before it, so the only other number it could be is 1, because anything times 1 would still remain itself. So looking at our graph, what's our y-intercept? So this curve crosses the y-axis at 1, and the direction is it is increasing. And when you take a look at our graph, press graph, you will see that. It does look like this touches the x-axis, but if we zoom in very closely, you see it would get very close to the x-axis, but it never touches it. And that looks exactly like our graph. Okay, let's look at our last example. Our last example is y equals 2 to the 1/4 x. So let's type that in the calculator. Go to y equals, clear what you have. 2 parentheses, alpha y equals 1/4. Okay, close your parentheses, caret to the x power. Second table to see our table of values. So now we take a look at this. So even though we usually say -3, there's no way we can graph 128 on this set of axes. -2 would be 32. We can't graph that. So we say -1/8. Well, that's a possibility. So let's put that in. 0, 2, we could definitely graph that. 1 1/2, absolutely. 2 1/8, yep. 3 1/32. going to look really close to the x-axis, but we definitely could do that. Okay, so let's take a look at graphing that. We have y and x. So when x is -1, our y value is 8, 5, 6, 7, 8. 0, 2. Start at the origin, 1, 1/2, midway. Start at the origin, 2, 1/8, very close to the x-axis. And 3, 1/32, really close to the x-axis. We would connect those points starting from the first one we see on the left, going all the way here. We know it's supposed to be a curve, so try to draw a curve as best you can. We do not use a ruler. We only use a ruler for a straight lines. Okay, put an arrow at each of the last dots to show this goes on forever. And you're writing your equation somewhere by that curve. Press graph on your calculator to make sure that that matches what we are seeing. And that does. All right, so taking a look at this, remember we're comparing this to y equals ab to the x. So what's our a value? It's 2. Our b value is 1/4. Okay, what is our y-intercept? Looking at this, our y-intercept is 2. And what is the direction of the graph? Going from left to right, our graph is decreasing. So take a look at your A and B values for each of the graphs and take a look at what our y-intercept is and our direction and see if you can find that pattern. Pause the video and okay, let's see what you discovered. Well, first off, the graph of an exponential function is a what? You got it, it's a curve. Did you find out what the A value is? I looked at the A value, I looked at this. A value and here, A value and here. So the A value is the y-intercept. Without even graphing, we will know just from the equation of a function where that curve is going to cross the x-axis, if this is our basic function. Now these two were increasing, and when you looked at the b value, you might have realized that if I took the absolute value of b, the absolute value of b of 2 is 2, absolute value of this is 3/2, which is 1.5. It increases if that value is more than 1. But notice that this decreased, and when I looked at my b value, I noticed that my b value is less than 1. So when I take a look at my b value, if it's more than 1, I know my curve will increase. You can't say a fraction because this was a fraction, but this fraction had a value, this fraction had a value of more than 1. This fraction had a value of less than 1. So if the b value less than 1, it's going to decrease. If the b value is greater than 1, it increases. And that's not only how we graph an exponential function, that's how the equation tells us so much about the graph before we even graph it. This has been your SOS video on graphing exponential functions.